Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and good morning to all of you. So today we discuss about the tutorial one, part one. Right. So I think you can download this tutorial on the Microsoft Teams. Right. So let's go for the tutorial one. Tutorial one, part one. All right. So you can see the question number one. What is the difference between the analogs and the system, the signal? So this one you can refer the slide, or you can refer the reference book, or you can refer the textbook. Okay, so analog is the continuous lah. It's a keyword that you have to remember. So the analog is the keyword for analog is the continuous signals. Okay, continuous signals. And then for digital is the discrete signal. That means step by step lah. Okay, this is some example. Okay, so this is some example lah. So this is a analogues, okay, continuous signal, and this one maybe in the discrete, something like this. It's a discrete signal, step by step lah. Okay, so there's a difference between the uh, analogues and digital signals. All right. So second question: why do we need to use the digital representation to describe the analog system? Right. So this one also can refer on the textbooks. So it must easier. I think this is the advantages of the digital. Okay. So it must easier to perform uh, the analog information in digital signals when we want to computer and electronic machine to interpret, communicate, and store and manipulate the analog information. Right. So this you can refer to the textbook or you can refer the slide. Okay. List the advantages and disadvantages of the digital system over the analog lah. So we have a lot of advantages such as information storage for further manipulation, okay, accurate, precise, okay, noise immune, okay, easy to design, simple, and so on. Okay, and then the disadvantages or limitation of the digital is the real world is the analogs, and then the processing time take time. The processing for digitize will be take time. Okay, the process to convert using the digital will be take time. Okay, so they have a process that involved to convert from analog to digital. That's how we take times. Okay, I think this one you can refer to the textbook lah. This okay, question number one, number two, number three. I think you can refer to the reference lah. You can refer to the slide, or you can refer to the textbook. Okay. So and then question number four, draw the waveform for the following binary information. Determine the most significant bit and least significant bits. Okay, rising and falling edge for each waveform. Right. So I will show you example. So we have a 0, 1, 0, 1, 1, 1. Okay, we'll do the one here, and then 0, 0. Okay, for example, so this is 0, 1, 0, 1, 1, 1, 0, 0. Okay, so this is the digital waveform lah for this one, and then you can see. So this is this one is the least significant bit. Okay, from this one we know this is we call the least significant bit, and this one will be most significant bits. And then rising and falling, you have to remember or we call positive edge trigger or negative edge trigger. So this one we call a positive edge trigger. Alright, so this one will be negative edge trigger. Alright, so this one from positive edge trigger will be from 0 to 1. So from 0 to 1 so this is we call the positive edge trigger, okay, or rising, and then this falling or negative edge trigger. Alright, so this is positive edge trigger and negative edge trigger or falling edge trigger. Okay, alright, so I go another example here. Okay, for example, question D. D. Okay, we have 1, 1 1. Okay, maybe can do like this, a bit too different. And then 0 1. Okay, we have 0 1, another one here. All right, so maybe like this, 1 1 1 0 1 0 1 1. Okay, so this is the digital waveform. And then, okay, as you know, so this is a uh, the least significant bit, and this one is the most significant bit. Okay, so whatever you can write like this. This is a most significant bit, and this one will be least significant bit. And then you have to determine, so this is a positive integer or rising integer, and then this is falling integer, and then this positive, negative, positive, and negative integer, right? So that is question number 4. Okay, and then for question number 5, convert the following binary number for their equivalent decimal value. Right, so this one, okay, you can use the manual or you can use the uh, calculator lah. Alright, so okay, for example, okay, you can use the calculator or you can use alright, I will show, okay, straightforward lah. So this is a binary convert into decimal lah. That means base of 10. Okay, decimal is the base 10 lah. Right, so you can do like this. I will show here one example. 0 1 0 0 1. Okay, so this is 2 power of 0, 2 power of 1, 2 power of 2, 2 power of 3, 2 power of 4. Okay, so this one will be 1, this one will be 2, this one will be 4, this one will be 8, this one will be 16. Okay, so 1 multiplied by 16, 16 plus this one is 0, and then 1 plus 4, 4. Okay, 1 multiplied by plus 2 plus 0 lah. Okay, so equals to 22. Okay, that's 10 lah. Alright, so this is for question number 1. The answer will be 22. Okay, so I will show another example. Alright, so this, okay, so another example like question C. C. So we have 1 1 0 1 1 decimal point. Okay, 0 1 0 1. Okay, so you can do the manual or you can straightforward using calculator. So for calculator you can solve this one, okay, using direct solve using calculator, but this one you have to use the manual lah. Okay, the manual. All right, so I will show same will be same solution. Okay, start from 0, power of 1, 2 power of 2, 2 power of 3, 2 power of 4. Okay, so this one will be 2 power of 91, 2 power of 92, 2 power of 93, 2 power of 94. Okay, so this one will be 1 2 4, okay, 8 16. All right, so 1 power of 1 multiplied by 16, 1 plus 8. Okay, this one 0 plus 2 plus 1. Okay, okay, so will be plus. So this one same as the 1 power of 1. Okay, this one 1 of 2, 1 power of 3, and then this one 1 power of 4. So this one will be plus 1 power of okay, this is 4. Okay, plus 1 over 16. All right, so you can using your calculator to total up this one. So the answer will be for the C. Okay, 20. This one 10. Okay, 27.3125. Okay, power of 10. Okay, this is decimal lah, in decimal. right? This is for question C. Okay, so I think we try another example here. Okay, for the F. Alright, for the F, I think you can solve using similar techniques. Alright. Okay, so 0, 1, 1, 0. Okay, point 0, 1, 1, 0. Okay, this one 2 power of 0, 2 power of 1, 2 power of 2, okay, 2 power of 3. Okay, so this one will be 8, 4, 2, 1. Okay, so 0 plus 4 plus 2, okay, plus, okay, so this one negative 1, negative 2, negative 3. Okay, so plus 1 over 4 plus 1 over 8. Okay, so the answer will be 6.375, okay, in decimal. Okay, so that is for question F. Alright, and then you can use question number 6. Okay, convert the binary number in problem 5 in the hexa and octal. Okay, in the octal and value lah. Alright, so this one you can, okay, you can straightforward using the calculator, or you can use the manual lah. Okay, so for example, right, for this one, okay, this is power of 10, so convert into decimal will be 16 power hexa, in hexa, and then this is 26 octal, right? So for hexa, you have to remember that for hexa you have to divide by 4. Okay, for example, this I will show some example here. One. Alright, so for hexa we have to divide by 4. Make sure start from least significant bit, 1, 2, 3, 4. So this one, cut 1. Okay, so this one will be 1, and this one 4, and plus 2 will be 6. That's why the answer will be 16. Okay, 1, 6 lah. Alright, and then for another example here, 0, 1, 1, 0. For octal, divide by 3. For octal 8, you divide by 3. 1, 2, 3. Okay, this one. Alright, so and then convert into this one will be 2, and this one will be 6 lah. So that's the octal. Alright. Okay, so maybe we try this one now for B. I will show, for example, another one. B 1, 0, 0, 0, 1, 1, 0, 1. Okay, for hexa, you have to divide by 4 from least significant bit. 1, 2, 3, 4. Here. Okay, 1, 2, 3, 4. Okay, so this one lah. Alright, and then okay, so this one will be, okay, so the answer will be 8. Then this one, okay, 8 plus 4 plus 1. Okay, it's the D. Okay, it's the D here. D. Alright, so the answer will be 8D in hexa. Alright, so for octal, you have to divide by 3. Okay, so 1, 2, 3, 1, 1, 2, 3, 1. Okay, so the answer will be 2 here, 1, and 1, 1, 4 plus 1 will be 5. Okay, hexa. Right, so that is the binary to the hexa or to the octal. So for hexa, you have to remember divide by 4. Okay, from least significant bits, and then for octal you have divide by 3. Divide by 3 from least significant bit lah. So then this is a least significant bit, and this is most significant bit. Don't divide from the most significant bit. So you have to start from the least significant bits. Okay, and then question 7. Okay, and then 7 will be convert this octal value to binary. Alright, so this one you can use the manual, okay, and then double check using your calculator lah. Okay, so this is octal value. Octal, that means power of 8 lah. Alright, to binary. Okay, and then this is octal. Okay, all in the octal you have to convert into binary lah. So for example, this one will be still alright. So will be, and then so you can use, for example, similar like question number 6. Okay, for example, you have you can divide by 2 lah. Alright, 2, and then you can see so the answer will be 11110. Okay, that means 6. Okay, so alright, so this is a 6, this is a 3, so this is the binary. Okay, so that means you have to convert 6 in the binary, and you have to convert 3 in the binary lah, so you can combine to be like this. Alright, so maybe I will show another example. 473, so like this, so 3, okay, 4 and 7, so will be for 3 0 1 1, okay, for 4 1 0 0, and for 7, okay, 4 plus 1, okay, plus 1. Okay, so that is the answer. Okay, so you can check your answer lah. Alright, so the answer will be 1111000011. Okay, so that is the binary lah. Okay, clear this one so you have to separate lah. Alright, so split by 3, similar like this one lah. Alright, similar like this one, split. So this one will be 000, and then 000, then this one 00, and then we have 10 lah. So we have 0 10000000000. Okay, so this is the in the binary. Okay, and then similar like this okay, so this one. Okay, alright, so then we go for the next. Okay, next is the convert 8. Question number 8, convert the octal number in the sevens to decimals and hexa decimal. Alright, so this one. Alright, so okay, from this one you already get the binary for binary, this one, and then automatically you can convert into the decimals. Okay, this one, for example, decimal or hexa. For example, I will show the binary. Okay, one example, 111000. Okay, and then 11. Okay, for hexa, divide by 4. Hexadecimal 1 2 3 4, 1 2 3 4. Okay, so this one will 1. Okay, and this one will be E, and this one will be 3 lah. Okay, in hexa. Right, and for using the decimals, okay, using the decimals, right, so this one you can or 0, okay, using the manual automatic, or you can double check with your calculator 1, okay, 2 3 4 5 6 7 8. Alright, so and then you can plus plus, and then this is the answer lah. Answer 483 in decimal so this one for question number B. Okay, and then the rest you can double check lah. For example, this one I will show D 10 0 0 0 0 0. Okay, so we have 1 2 3 4 5 6 7 8 9 10. Okay, so you can double check this one so 3 okay, 10. Then for hexa, divide by 4 1 2 3 4, 1 2 3 4. Alright, so this one 0 0. Okay, this one will be 4. Okay, and then in hexa. Okay, for for decimal, so this is 0 1 1 2 3 4 5 6 7 8 9 10. It means 2 power of 10 lah. 2 power of 10 equals to 1024. Okay. Alright. So in decimal lah. So this some example Alright. Okay. So next we go for the question 9. We convert each hexadecimal number to each decimal equivalence. Alright. So okay, this one. Okay, you can also this one similar lah. Similar like question number 7. So you have to divide by okay, this one divide by 2. So 2 but in the 4 bit 4 bit because we divide by 4 4 bits. Okay, this means 2 lah. That means 0 0 0 and then 9 1 0 0 1. Okay, 4 8 plus okay 9. Okay, so this is the binary, right? Okay, and then to convert, okay, so this one, okay, and then for example like this one okay, so you can split by 3 lah. Okay, and then you can divide 6. Okay, 6 4 1 2. Okay, for 1 2, and then for a 0. This one 1 1. Okay, and this one 1 0 1 0. Okay, so the answer will be 1 1 0 1 1 1 0 1 0 0 1 1 0. Okay, in binary. Alright. Okay, similar like this one so you can, so D in the 4 bits. Okay, so D is for example 1101 1101. Okay, and then for E 1110, and then for F 1111. Okay, you can convert and then combine, so this is the answer okay, similar like this similar like this, you can split and then divide by 4 bit 4 bit 4 bit 4 bit. Okay, for 9 change to binary, and then for 4 change to binary, and then for 5 change to binary, and C change to binary, then combine so that is for hexadecimal convert into decimals. And then question number 10 will be related to question number 9 So from this hexa value 92, you have to convert into binary. Alright, so already convert into binary, and then this one you have to convert to decimal decimal so for example this one. Alright, so first is the same step, you have to convert into binary. Alright, then you can convert into decimal for example this one 2 power of 0, power of 1, power of 2, power of 3, power of 4, power of 5, power of 6, and power of 7. So you can total out. Right, so total out this one will be 100. Okay, 146 in decimal okay, and then for example like this one for B okay, or so you already convert to the binary. Okay, you can use the manual 0 1 2 3 4 5 6 7 8. Okay, and then you can plus so the answer will be 422 422 in decimal and then alright, so actually the question number 9, so we are already solved for the binary. So first, okay, from hexa you can convert to binary, alright, and then convert to octal. Okay, for example like this one I will show an example. From binary you can convert into octal by just you perform the divide by 3 okay, 1 2 3 1 2 3. Okay, so this is the 2 2 2. Alright, so the answer will be in 8. Okay, and then for example like this one 1 1 0 1 0 0 1 1 0. Okay, so 1 2 3 1 2 3. Okay, so the answer will be 6, 4, 6, okay, for 6, 4, 8 lah. Right, so this is the answer for question B. Okay, right. And then 11, we go for the 11. Okay, list the octal number in sequence for. Okay, so for apa 8, 5 in octal until 15 in octal. So you can just show some example here. So the number is 5, 6, 7, 10, 11, 12, 13, 14, and 15. Okay, so that is the sequence the number in sequence from this one. Okay, 5 octal to the 15 octal. Okay, another example for B. Okay, this one will be 44, 45, 46, 47, 50, 51, 52, 53, 54, 56. Okay, 55. Right, so this is a sequence, the number sequence in octal from 44 octal to 55 octal lah, right? And then so on. This one you can try. Okay, so next for list of the hexa number in sequence. Hexa number in sequence. So some example here. All right, so we have a 5. Okay, this one 5, 6, 7, 8, 9, E, B, C, D, E, F, 10, 11, 12, 14, 13, sorry, 15, 14, 15. Alright. So this is sequence for this one, and then you can try for this one, 44 pin. Right, so I will show some example here for D. This one for D from 27, 27A, 27B, 27, 7B, 7C, 7D, 7E, 7F, okay, 80, 81, and 82. Okay, and do this one, So this one. Alright, so we go for the next. Okay, so this is arithmetic, in additions and subtraction. Okay, so this one I think for decimal you can straightforward add. Okay, you can add straightforward. For example, this one just 27 plus 44, and then another example. Okay, 11. Okay, this one I think so. This is same. Okay, this is same. You can straightforward add. Okay, but this one 1 plus 1 plus 1 1 0 1 plus 1 1. Okay, 1 1 0 1 plus 1 1. Okay, right, 1 plus 0 1. Okay, so 1 plus 1 0, bring here 1 plus 1 0, bring here 1 plus 1 0 1. Okay, so that's the answer right? So straightforward, but make sure the base will be same If not, for example, like this one we have to change. Okay, for example, change octal to binary, then you can add Okay, for example, there's a different base here, different power here, different numbering system lah. It's different, so you have to convert either one lah. You want to convert to decimal or you want to convert to octal. Right, for example, this one it will be same. Binary, in binary you can add something like this. Okay, this one plus lah. Okay, for example, this one straightforward lah. Okay, straightforward. Decimal you can add just okay, straightforward. Okay, and then this one but this one binary, but this one in the decimal. Okay, so you can convert 17 to binary, then you can add. Okay, or this one. Okay, so you convert to decimal, so will be 3 lah. Okay, this one will be 3, and then plus lah. Okay, for example, 3 power of 10, so 70 plus 3 will be 20. Okay, will be 20, for example, 20 in decimal. But in the binary, you can convert lah. Binary in decimal, you can use your calculator, or you can manual lah. 1, 0, 1, 1. Okay, so this is 20 lah. 16 plus 4. 16 is 16 plus 4, so will be 20 lah in binary. Okay, make sure it will be same. It will be if the same, you can add directly lah, or not. For if, for example, like 16 here, hexa. So if, for example, it's quite tough, so maybe you can change to binary. Then binary can add the binary lah. So that's the another example lah that you can try. Okay, for example, like this one. Okay, so we have 16. So hexa. Okay, A. Right. So 4, 4, 4. Okay, and then plus 1, 101 lah. Okay, so in binary, so this one I will convert into binary. So the answer will be 1, 0, 1, 0, 1, 1, 0, 1, 2, 3, 4, 5. Okay, so this is the binary. Okay, because this one I change to binary, then plus this one lah. Okay, for if and then convert into hexa. 1, 2, 3, 4. Okay, 1, 2, 3, 4. All right, so this one will be A, this one will be D, this one will be F. Hexa. Right, so this is the answer, binary in hexa. Okay, for simplicity lah, for example, like this one, I will change to binary, convert into binary. Okay, for example, convert to binary and then plus this one. Okay, just if binary, just can using the same operation like this one, just add as a simple adding lah. Okay, 1 plus 1 is 0, bring carry 1 lah here. Okay, for example, the answer here will be 1, 0, 0, 0, 4, 0. Okay, 4, 0, 0, 1, 0, 0. Okay, then divide by 4. 1, 2, 3, 4. Okay, 1, 2, 3, 4. Okay, so this is binary, then 1, 0, and then this is a 1, 0, 1, 1 is the B. Okay, so in hexa. Okay, that is the answer lah. Okay, for this one, binary and hexa. Okay, for simplicity, maybe you can change to binary, then add, then you can, from the binary you can convert into hexa again. Okay, that is the technique lah. All right, so the last one is the subtraction. All right, so this one. Okay, so this one is straightforward. The same, just straightforward lah. It's okay. You can use straightforward. For example, like this one. Okay. Okay, for subtraction. Okay, subtraction. Okay. Another B, maybe 1, 1, 0, 0, minus 0, 1, 1. Okay. Okay, just subtraction. Okay, so this one. Okay, sorry. Well, so we borrow this one. 0, 1, 1. Okay, 1. This one. Okay, so will be 0, and then cannot bring here, so will be 1. Okay, 1. So the answer will be 1, 0, 1. Okay. So this is the answer for question B lah. Okay, B. So this one, okay, is the same power, you can direct lah decimal. Okay, or for another example here, okay, another example. So for example, this one I just for binary I just straightforward. Straightforward, you can subtraction, or another one you can change to decimal. And then you can from decimal you can minus lah. For example, we have 3, 4, one 8. Okay, 8 plus 4, 14. Okay, this one 8, 4 plus, okay, minus 7. Okay, it will be 5 lah. Okay, this one will be 5 in decimal. Okay, similar like this. Okay, or convert into decimal, then you can just minus as a normal lah in decimal, similar like question number 1. 27 minus 19, so the answer will be 8. Okay, in decimal. Alright, so this one, okay, for example, we have the octal. Okay, for octal, you can convert into binary, or you can convert into decimal. Then you can okay, you can minus the as a normal binary or the decimal. Then you can convert again to the octal lah. For example, the answer for C will be 267 octal. And then for D will be the answer will be 3. Okay, 343 in hexa. Alright, so today you can try. You can try double check with my answer lah. Okay, E will be 11 in decimals, and 1011 in binary. Then F will be 100 binary. Okay, 100, and then is the 48. Okay, and then this one BO, then 260. Okay, H is 66 but in octal, and 54 in decimal. Alright, so 1100, 1 in binary, and 19 in hexa. Okay, so the last one 14 hexa, and binary will be 10100 in binary. Okay, so this is the answer lah for question number 14. You can double check lah. Okay, is it correct or not? So okay, make sure so it will be same numbering system lah. If not, so you have to change either one lah. Which one you familiar? Okay, you want to change to binary, or you want to change to octal, up to you. For if we have same numbering system, just straightforward. You can, for example, for decimal you can add, okay, or straightforward to minus lah. Okay, for example, is the difficult. Okay, for example, we have difference. You can convert into, I think for simplicity, you can convert into binary. Then you can use the operation of using the binary. Then you can convert into what numbering system, for example, the octal or hexadecimal lah. Okay, for example, after you get the binary, you want to convert into hexa, so just you remember, divide by 4. Okay, divide by 4. If octal, you have to divide by 3. If you have the binary, from binary lah. Okay, for example, like this one. Okay, this one, okay, in binary, so you want to convert into hexa, so divide by 4. 1, 2, 3, 4. Okay, so the answer will be, okay, 0, 1, 0 lah. And then for convert into octal, divide by 3. Okay, this one 2, and this one will be 0. That's the how to from binary convert into the hexadecimal and octal lah. Okay, right, so you can try at home. Okay, to tutorial 1 part 1. All right, so we finish, okay, for tutorial 1. Okay, so next we will discuss on the tutorial 1 part 2. Okay, thank you very much. Okay, assalamualaikum warahmatullahi wabarakatuh.